Hey, hope everyone's doing okay. Today in O-Level Physics, Lesson 4, Forces, Newton's laws, moments and stability. A force can change velocity, direction, or shape. Forces include weight, normal contact force, friction, drag, tension, and upthrust. Draw a free body diagram showing only forces acting on the chosen object. Combine forces as vectors to find resultant force. If 18N acts right and 11N acts left, the resultant is 7N right, not 29N. Newton's first law states that an object remains at rest or at constant velocity unless a resultant force acts. This is inertia, the tendency to resist change in motion. See how the arrow for velocity can change length or direction. Acceleration is that rate of change, so you can accelerate even while slowing down, or while turning at constant speed. Balanced forces do not imply that an object is stationary, they imply zero acceleration. A car at steady speed can have driving force equal to resistive force while both forces remain present. See how the arrow for velocity can change length or direction. Acceleration is that rate of change, so you can accelerate even while slowing down, or while turning at constant speed. Newton's second law links resultant force, mass, and acceleration. Force equals mass times acceleration. A resultant force of 12N on a 3 kg trolley gives A equals 4m over s squared. For the same force, greater mass gives smaller acceleration. See how the arrow for velocity can change length or direction. Acceleration is that rate of change, so you can accelerate even while slowing down, or while turning at constant speed. Newton's third law states that interacting bodies exert equal and opposite forces on each other. These forces act on different bodies, so they do not cancel on one free body diagram. A moment is the turning effect of a force. Moment equals force x perpendicular distance from pivot. Only the perpendicular distance from pivot to the force's line of action is used. A 25 north force acting 0.40 m from a hinge produces 10 Nm. Increasing handle length increases moment, explaining why door handles are placed far from hinges and long spanners loosen tight nuts. 4 EEQLIB micrometers, resultant force is 0 and total clockwise moment equals total anticlockwise moment about any pivot. Choosing the pivot at an unknown support can remove that force from a moment's equation. A 300 north child 2.0 m from a pivot balances a 500 n adult at distance d, 300 times 2. 0 equals 500 d, so d equals 1.2 m. The center of mass is the point through which an object's weight acts. An object topples when the vertical line through its center of mass falls outside its base. A wider base and lower center of mass increase stability, which is why racing cars are low and cranes use outriggers. Stability does not mean the object has greater weight, it concerns geometry and turning effects. Draw and label a free body diagram, choose a positive direction, calculate the resultant, and apply force equals mass times acceleration. For moments, mark the pivot and perpendicular distances, then equate clockwise and anticlockwise totals. A 20 north load acts 0.30 m left of a pivot. A force F acts 0.50 m right. EEQLIB micrometers gives 20 times 0. 30 equals Fx 0.50, so F equals 12N. Vertical support forces must also balance. Do not pair third law forces on the same object, use sloping distance instead of perpendicular distance, assume balanced forces mean no motion, or check moments without also checking forces. Practice. A 1,200 kg car has a resultant forward force of 2,400 N. Find acceleration. Answer: A equals F, all over m equals 2,400, all over 1,200 equals 2.0 m over s squared. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Practice. A 40 north force acts 0.25 m from a pivot. What force at 0.50 m balances it? Answer: 40 times 0. 25 equals fx 0.50, so f equals 20 n. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. We'll leave it there for forces, Newton's laws, moments and stability. Next time in O-level physics, we'll get into momentum, impulse and collisions. Hope that helped. Catch you next time.